A promising discovery has been made that could one day help in the fight against cystic fibrosis. And the researcher behind it is 16 years old. Marshall Zhang is a high school student in Toronto. Using a supercomputer, he developed a new drug cocktail that could revolutionize the way doctors treat CF patients. Marshall also recently won a national biotech competition for his work, and he's with us in our studio this morning. Welcome to you. It's good to have you here.
It's nice to meet you.
So tell me, first of all, Marshall, why CF? Why the interest in that?
Well, actually, I just, in grade 10, I was just interested in biology in general, and I was really wanting to get a taste of science in the real world, in the lab, and so I sent out a few emails to some professors and asked, hey, can I help out in your lab? And the response wasn't so great just because I was a high school student. I didn't have that lab experience needed, and so at the beginning of this year, Dr. Christine Bear at the University of Toronto.
Because she did respond, right? She was the one person that said, oh, okay, I think I can help.
Yeah, I was actually down to, I think, just a few professors left out of that list of biochemistry faculty at U of T, and she said, hey, you know what, you can come in and we can work something out. And from there, she's actually the co-chair of the Cystic Fibrosis Research Center, so that's how I got involved in cystic fibrosis.
And you self-studied this. This wasn't curriculum that was happening at your high school. You had an interest in this. And basically taught yourself and investigated all of this yourself.
Yeah, a lot of my work was actually based on the computer, and to access the supercomputer, actually, you would have to type in the code and everything. It was like looking at the matrix. And so the first time I did that, I had never done any of this computer computational stuff before, and so I did this, and I had to really learn everything from the beginning, and I guess it was tough at the beginning, but I think it's paid off. So.
I would say. Tell us more about your discovery and what it means to cystic fibrosis and fighting it moving forward.
Well, basically, throughout my studies, computationally and experimentally, I've really been able to find out how certain molecules are able to correct the basic defect causing cystic fibrosis. And through my computational studies, actually, I predicted that if we used both compounds at the same time, they would actually work together in correcting this defect. And originally, I thought it would just be maybe a 1 + 1 = 2 kind of thing. But when we got our results back from the lab that day, it actually turned out it was not just 1 + 1 = 2, but 1 + 1 = 3. And the two compounds were actually working together synergistically with each other to correct that disease-causing defect. And that was really exciting. And beyond that, I've also laid a foundation for future structure-based drug design and identifying certain chemical structures that really have a key role in correcting that defect.
How surprised were you, Marshall, when this actually actually worked? Because really, I mean, you hear about things like this, and oftentimes in the first or second time, it doesn't come together, but this really did for you.
Exactly, yeah. In science, a lot of the time, you make your hypotheses and you do the experiment, and it just doesn't work out. And actually, I only had a week to go in and do the experiment. There was only time for a single experiment.
Wow.
Because I live in Richmond Hill, and it's kind of a long commute down to sick kids. And so I had planned out my experiment, and I went in for that week, did the experiment on that Friday afternoon. My last day, we took out the results, and it was just, wow, like you don't believe what you're seeing almost. And it was amazing. I think it's really rare on the first time for an experiment to work, especially the first experiment ever.
I would think so. And we know that the drug developmental process takes some time. So how long do you think it'll take? Because this is a first step, right?
Absolutely. Drug development 15, 20 years down the road. Right now, we've shown that these two compounds do have this effect in the cells, allowing the cells to function as if they were the cells of healthy individuals, but with cells and in a human body are two completely different animals. We would have to test for toxicity and how the human body metabolizes all these compounds. And certainly, although this is a first step for these two compounds, it is a long way from developing these drugs. But I think what's more important about my project is that laying of foundation and identifying these common chemical structures that we might be able to use in different compounds in the future, and being able to design compounds around these chemical structures.
An important step, and you're off to another competition in June in Washington, right? An international one.
Yeah, it's the International BioGenius Challenge, and I'll be competing with 2 teams from Canada as well as 10 teams from the US and 2 teams from Australia. And that's going to be really exciting.
We do stories all the time about young people in trouble, and I'll tell you, the future is in good hands if you're representative of it. This is amazing. Thank you for coming in. Good luck in June.
Thank you.